class we shall learn about triangle inequality. Triangle inequality. This is very important for your examination purpose. The general questions there may be from here, and it will also be very effective to solve some problems concerning this chapter. You have to know this triangle inequality very carefully, and its proof is also very important, very important. So let us now start. Here we have Euclidean space V on which the inner product, this function, notationally you already familiar with this, in a parenthesis by a single comma, this is the inner product function on V. We have considered this Euclidean space V, and we have also considered two vectors alpha beta from V. Then the triangle inequality tells us norm of alpha plus beta. Alpha beta are two vectors from this vector space V, Euclidean space V. So we can add them according to the vector addition rule, that is the component wise addition, and we have considered this composed vector alpha plus beta, and we are considering the norm of this vector, norm alpha plus beta. This will be less than or equal to the summation of the individual norms of these components vectors here alpha and beta. That means norm alpha plus beta less than or equal to norm alpha plus norm beta. So let us now see how can we show this. Recapitulate the definition of the norm as we have discussed in our previous class. Norm alpha plus beta, this is norm alpha plus beta, this is actually the positive square root of the functional value alpha plus beta comma alpha plus beta. This is the definition of the norm as we have already learned. Where as this is a square root, to omit this root we are considering the squares on both sides, that is norm alpha plus beta whole square. This is equal to alpha plus beta comma alpha plus beta. This is the addition of two vectors alpha and beta. We are just separating this. So this will be in such form alpha comma alpha, this is first, next is beta and alpha, that is beta comma alpha, third one will be alpha comma beta, that means alpha comma beta, and fourth one will be beta comma beta, this is beta. So let us now see again what we have done here. Let us now see again what we have done in this line. First component alpha, we are considering this first component, so alpha comma alpha. Next beta, first component alpha, this is beta comma alpha. Third one we are considering first and it's the second component, that means alpha comma beta, and fourth one is this second component beta and this second component beta, so this is beta comma beta. And according to the definition of norm alpha, this will be equal to norm alpha square. And we know the first property was the symmetry property for a inner product function. So beta alpha will be equal to alpha beta. Just we have written here this beta alpha equal to alpha beta. This was the symmetry property for a inner product function, for inner product. So in place of beta alpha we have written alpha comma beta, and this is alpha comma beta, and beta comma beta is obviously equal to, according to the definition, norm beta square. So this is equal to norm alpha square plus 2 alpha comma beta plus norm beta square. Here look at this rough work. According to the Schwarz inequality, we know the modulus value of alpha comma beta less than or equal to norm alpha into norm beta. If we omit this modulus sign, this will also be equal to alpha comma beta less than or equal to norm alpha into norm beta. So we have used this here. So alpha comma beta less than or equal to norm alpha into norm beta. We have multiplied 2 on both sides. This is 2 into alpha comma beta less than or equal to 2 into norm alpha into norm beta. We have added on both sides norm alpha square and norm beta square. So this is equal to less than or equal to norm alpha square 2 norm alpha into norm beta plus norm beta square. What we have done here? Merely we have added norm alpha square and norm beta square on both sides of these inequality. Clear? So what we can write from here? This is less than or equal to norm alpha square plus 2 norm alpha into norm beta plus norm beta square. So we have used this line here. So this will be less than or equal to norm alpha square plus 2 into norm alpha norm beta plus norm beta square, and this line is equal to norm alpha plus norm beta whole square. So ultimately what we have obtained? We have had norm alpha plus beta whole square. This is norm alpha plus beta whole square less than or equal to norm alpha plus norm beta whole square. So we have written here norm alpha plus beta whole square less than or equal to norm alpha plus norm beta whole square, as we have obtained from here. This is less than or equal to norm alpha plus norm beta whole square. Now we have just taken the positive square roots on both sides. So this implies norm alpha plus beta less than or equal to norm alpha plus norm beta, and this inequality is called triangle inequality. The proof is very important and carefully read it. Thank you.